Well, hello, hello. Man, you guys are sitting a long ways away. That way I have to throw things a long distance. I don't have anything to throw. Okay, we're going to have some fun in this next session. We're going to kind of dig into Kubernetes in a little bit. How many people here have tried Kubernetes already? Okay, a fair number of you. So hopefully for those people who have tried it already, you'll see a few tips and tricks here that you didn't know about already. And for those of you who have not tried it, you'll get a little introduction to it. Now, I don't plan to spend much time on the introduction side of things. We want to kind of show you a bunch of different clever tips and techniques. And then I have some very complicated demos which may or may not work. That's the nature of how I set these demos up. As a matter of fact, I had to restart the thing right before we got here, so we'll see how it plays out. So in this world, the link that you want is the bit.ly link, 8 steps to awesome, 8 steps awesome. That'll give you access to the slide deck, and it'll give you access to all the links inside the slide deck. So make sure you have that bit.ly link there. I tend to open source all the slides and demos associated with what you see here. My name is Burr, Sutter. I'm responsible for developer experience at Red Hat. That means I go out and spend a lot of time talking to developers about their needs, their desires, what they want to see, and then working within the open source community, working in Red Hat engineering to help those things happen. So I'm excited to be here, my second time to the Ukraine, and it's always an awesome conference to come here and see JavaDay. You guys are super lucky to have a conference like this in your community. I can tell you that I go all around the world, and there's very few opportunities like this for Java developers to get together in their local community and have a vibrant local community like this one. So you guys are really, really lucky. So make sure you thank your organizers, okay? Let's dive in. You saw this from me last year. I showed this chart before. I do think of this as a journey, all right? Meaning we want to get all the way to the microservices world. We want to get to the world where we can deploy 25 times a day, like you hear the unicorns in Silicon Valley doing. That's why I use a unicorn up here. That's the GitHub unicorn. But you have to think in terms of going through the journey specifically from a DevOps standpoint, of working within a DevOps culture, working within your operations team. Think about self-service on-demand elastic infrastructure. Think about adoption of containers and Kubernetes. Think about CI/CD and the deployment pipeline, and of course, advanced deployment techniques. We're going to cover a few of these things in this session, and we're going to mostly focus on Kubernetes. So my presumption here is that you folks wish to learn more about Kubernetes. Is that cool? Awesome. Now, this is one of my favorite images. I worked with the design team to come up with this image, but look at what this image tells you. Have you guys ever heard the story of pushing the stone uphill, pushing the rock uphill? Has that translated to this part of the world? You know, so basically it feels like it's a lot of work to push a stone uphill. Well, this is actually how I see software delivery in modern enterprises. It's not a nice stone, it's a big amorphous blob that no one's really sure what it is. And as a matter of fact, there's a gang of people trying to push it up the hill. And there's also people pushing it back down. And so you have to think about that for a second. Who is this guy right here? If you're a developer, you're going, that's the operations people. And that's not the operations people. We know better. That's the DBA, who's always telling us no, right? And maybe it's this person up top here. Who's that? You guys know who that is. It's your architect. They think they got to ride on top of this thing, right? And then really your operations person is this poor soul at the bottom, which unfortunately might just covered up. But it's the individual at the bottom of that blob, you know, struggling to keep that mass afloat. So what we want in the future of this world, and by the way, by the time we clear the first hurdle, you got to do it again and again and again. So you want to make software more humane. You want to make it more fun and more interesting, and you want to make it less painful. And a software delivery should look like this, where everybody's working in the same direction, pushing in the same direction with a nice, cohesive, modular piece of software that rolls nicely uphill, at least, and is not some amorphous blob. So I use these images to kind of make that point, and the tools we're going to talk about in this next section hopefully will help you do that, hopefully help you deliver software faster. Because at the end of the day, it doesn't matter what we do as software developers. If we can't get our application code to production, guess what? Your code offers zero value to the enterprise and the business and organization that you work for until it lands in production. I don't care how many code smells you eliminated and how amazing unit tests you've created. It matters not at all until it lands in production. So that's got to be our focus. We got to offer business value, offer organizational value. Okay, here's the 8 steps. You can see I actually have a 0 and an 8 and a bonus section. So we're going to kind of fly through parts of this. I'm not going to spend too much time on the introduction, and we're going to dive right into more of the getting started experience, how to build images, how to run those images, and just basically tips and techniques associated with using Kubernetes. Okay? So let's kind of fly through this piece. We did this earlier in the earlier session we did. But the concept that you would want to describe your application stack is super important. And you can do that within a Docker file very easily now. It matters because we need to stop emailing the specification to people. We need to stop, building a wiki page, which gets outdated very quickly with the specification. We need to codify the specification. A Docker file is very useful for that. And of course, that means we communicate the needs of our application better with the operations team. So I do see the value of containers from that perspective. So again, looking at a Docker file, you would describe your application perhaps this way. It doesn't matter what app server you're using, as long as you're using Java, right? You can use FatJar deployment or app server deployment. It doesn't really matter. You're going to describe it a certain way, and at least it's codified now. There's a whole Docker tutorial available there. We're going to kind of skip that. We're going to talk briefly about Kubernetes. And the idea here with Kubernetes is that it's an orchestration solution to deal with all those compute nodes and make sure your Docker containers are running happily on them. That's really the focus of it. And it has these main concepts, the pod. And the pod's important because that's actually more than a single container. And we're going to see an example of that. If my last demo runs, you're going to see an example running more than one container in a pod. And that's actually where things get really, really interesting. So that's why they call it a pod, not a container, because it can run more than one container. And more importantly, if you guys are familiar with the symbol for Docker, which is like a container ship that looks like a whale, well, a pod is a family of whales. So you can group them together, keep them together. So that means everything has all these containers have a common life cycle, they have a shared IP, they have shared storage. They all can see each other, okay? They live in the same shared life cycle. You also have the concept of a replication controller or a deployment. We'll see an example of those if we get into it. But that idea there is it's a separate service, if you will, that ensures your pod stays running. So if you say I need 2 running, it makes sure there's 2 running in your cluster. If you say I need 8 running, it ensures 8 stay running. That's its job, is to keep everything up and running happily. And then you also have the concept of a service, which is a virtual IP, or virtual stable IP, so that you can actually map different pods behind it. So the service name stays the same. We'll show you an example of that. But the pods can change out from under it. And then labels. And all the magic kind of happens with those labels. You can label things like production, label things like development, label things like QA, label things like accounting. Kind of moves that way. So there's the family of whales and the definition for a pod. And of course, with your Kubernetes cluster, which looks something like this, there's a master node and multiple compute nodes. And then, of course, you can, achieve all these awesome things from a Kubernetes standpoint. It self-heals the environment, automatically restarts pods for you and schedules things across those different hosts. There's even a built-in load balancer across services. And it has a really nice feature for rolling updates. Maybe we'll get to that in the demo. Okay, there's a whole bunch of different Kubernetes commands you should get familiar with. So if you learned things like Docker run, Docker build, now you learn things like kubectl run, kubectl get, pods, get namespaces, and you'll start interacting with these guys also. So it's just another command line tool that you'll run on your Windows machine or your Mac or your Linux machine. There's a whole nice tutorial there, Kubernetes by example. And again, I told you we're not going to spend a lot of time on the introductory stuff. Now let's get into the more interesting parts of this. If you're dealing with a microservices architecture, and everybody wants to do microservices, right? Everybody's like, oh, I'm doing microservices. And you can ask them, how many microservices do you have? I've got 1. You guys see the joke there? Yeah, 1 doesn't count. That's a monolithic small application. It's just an application. So even 2 or 3 really shouldn't count. But once you start dealing with, let's say, 30 or 40 microservices, you got to have a way to manage them at scale, right? How do you keep all those things up and running? And that's where something like a Kubernetes really shines. So these are different FatJar solutions that you might have heard of before, right? And actually, last year I spoke on Vertex specifically. I have Vertex demos and Wildfly Swarm demos, Spring Boot demos. But it doesn't actually really matter what you build your microservice in, unless you're a Java developer, and these are one of the ones you're probably interested in. So let's tell you this little story. In a microservices platform world, I would say this is about 2014, 2015, what we were doing. So Netflix was born. You guys remember this thing called Netflix? The people who basically used to have a really great TV show and don't anymore, as of right now. But those folks basically reinvented TV back in 2012, 2013, with the release of House of Cards. They also reinvented enterprise software at the same time by open sourcing all their microservices frameworks, things like Eureka and Ribbon and Zool and Hystrix. So you would build a microservices stack this way in the previous generation of this. As of 2016, what I showed you guys last year was a demonstration where you can eliminate Eureka, eliminate Ribbon. You don't need them in a Kubernetes architecture. You don't even need the config server in a Kubernetes architecture. You kind of get that for free in the infrastructure, in the actual underlying technology known as OpenShift or Kubernetes. OpenShift, by the way, is simply Red Hat's name for Kubernetes. Think of Kubernetes as the Linux kernel. OpenShift is our distribution of that and how we support customers around Kubernetes. So I will interchangeably use the two terms and treat them the same way. And I will even switch the command line tools back and forth between OpenShift and Kubernetes because all it is Kubernetes. But some other additional features on top, which we'll see some examples of that. Now, that's 2016. We're already in 2017. And actually, so Zipkin is going to be leaving us soon. We're going to be interested in open tracing, which is a standard around the tracing API, and this thing called Jaeger, which comes from the Uber team. So it used to be it was all cool for Netflix to give us a bunch of cool middleware. Now we want Uber and Lyft to give us a bunch of middleware, and Jaeger comes from the Uber team. We still have Zool and Hystrix in the mix, though. So as of 2018, so we're kind of telling you guys the future now. There's this thing called Istio you're going to hear a lot about over the next several months. Istio is the absolute hotness of hotness. It is the most amazing thing ever. It's going to, feed the hungry, clothe the naked, just like microservices did back last year. You guys remember that? So Istio is going to be super awesome, and if I get my demo to run, you'll see why it might be super awesome. We'll show you that. Note also, though, the slide did change there slightly. If you do it this way, eliminating Zool and Hystrix, Eureka, and Ribbon, it doesn't work for only Java now. Like previously it was Java only. That's what the Netflix middleware did, Java. Now it works for every language with this new architecture. So if you want to be an all Python, Ruby, mixed Node.js with some Java, you could. And all those different microservices can run happily in this architecture. So that'll become more obvious when I get a chance to demo, if it demos correctly. Do keep in mind you have all these microservices properties to to worry about, like discovery, invocation, elasticity, resiliency. We spent a lot of time on that last year, but we may show you a little bit of that in the demo. Now, what are your 8 steps? First of all, you got to get a copy of this thing to make it work, okay? So there's multiple ways to get a copy of it. Minikube is super easy to install. You just download it and run Minikube on your local machine, on your Windows machine, your Mac, your Linux machine, and it's ready to go. There's also Minishift, which is, again, the Red Hat version of Kubernetes, the OpenShift version. And so you'll see me running it. Sometimes I run both. In this case, I'll just be running Minishift today. You can also run Kubernetes easily up a Google Cloud platform, obviously. It came from the Google guys originally, with Red Hat as a partner in that case. So you can easily launch it at the Google Cloud. But at this point, it runs on every cloud. Everybody's declared support for Kubernetes at this point. It doesn't matter who they are. If they had a previous platform as a service or a previous cloud solution, everyone's kind of come out and said, we do Kubernetes now. So you can run on AWS. You also have this thing called OC Cluster Up you should be aware of. If you have a Docker daemon today, you just download the OC binary, which is the OpenShift client, and you can do OC Cluster Up, and it'll install a cluster right there inside your Docker daemon, which is kind of crazy if you think about it. In other words, we're running a container platform in a container. That's what it looks like. There's also lots of other options. You can kind of just check those out there. Just to kind of show you what that looks like on this local machine here, I am curious to see if things were not behaving well when we got started. Let me actually do this real quick. I want to try to run this deployment. Okay, let that run. kubectl get pods. It's trying. Okay, so but basically, I'm running Minishift right here. Let's see here. You can see it's just a little command line tool, and you'll do things like add-ons, delete, start, create profiles, and you'll see I'll switch the profiles if I can. What's my Docker environment? The reason this one's important is if you want to run the Docker command line tool against it, you can do that. So come on, Docker env. So I'm using too much CPU. So if I do this over here now, okay, I can do Docker images, and I'm now using the Docker command line tool against that Kubernetes cluster. Okay, so you can see I have a ton of images in there, and Docker PS. And I got a ton of containers running right now. This is part of the problem. I have way too much running in this one machine. So this is just a little virtual machine running a VirtualBox. You can see here it is, right? I'm running 6 gigs of RAM. on that one, on 2 cores, and I have a ton of JVMs running. Okay, so just keep that in mind. I have a lot of different things running specifically in it, and then I have the little console here. So the nice thing about Minishift or Minikube, you can do a lot of really amazing things with it pretty fast, right? So like here's the actual demo we showed you guys last year. Basically it covers different microservices patterns, things of that nature, but I have it all running here. Okay, so we weren't going to spend a lot of time on that. Maybe we'll come back to it later, but that's part of what's running in this environment. So you can actually run a whole cloud on your laptop until you run out of memory. And you will run out of memory at some point. I've done that a few times. Let's see here. Okay, let's jump back into the presentation and keep rocking and rolling. We've got to move fast. Am I talking too fast? You can say yes. I'm originally from Hawaii, but I grew up in Alabama. If you know anything about the South, the South, Alabama is very southern, but I talk really fast. No one in Alabama understands me. And my mother still lives in Alabama. That's the funny part. Now, okay, we got a cluster up and running. Minishift, Minikube on your laptop, cluster up and running, super awesome. And there was another link up there for a Windows installer. For those people who love Windows installers and don't want to use the command line, there's a Windows installer also for people who want to just install on Windows. Once you have your cluster up, then you want to do things with it, okay? You can do the standard Docker build and Docker run. Like you saw me just do a Docker images, Docker PS. That works fine. You just got to make sure you're pointing at the right Docker daemon, and you saw me do that specifically with the Minishift Docker env, pointing me over at the cluster as opposed to the regular Docker daemon on the machine. And actually, that's probably the trickiest part, making sure you're facing the right cluster and not pointing to the wrong one. That tricks me all the time. Then once you want to build an image, there's lots of ways to build an image. The one I'm most excited about right now is the Fabricate Maven plugin, which I just actually executed before we started, because I had that deployment had not yet finished. Let's actually go see. What was it over here? Okay, so the Fabricate Maven plugin basically allows you to do something like this. By default, okay, there is no, that was number 3 that I was just running. Okay? Notice there's no Docker file in that project. It's just a standard Maven project, Spring Boot project, no Docker file. Maybe let's make that point a little bit more explicitly. Let's go here. Let's try this. Start spring.io. Okay? My JavaDay demo, just give it a new name. I want it to be web. I want actuator. You just pick your things. Pretty standard stuff from a start.spring.io standpoint. So this is obviously an empty project. Generate project, unzip it. There it goes. Yep. Come on. And I have, let's go over here. What do we call it? My Java demo. There we go. So you can clean, compile, package that, but there's no logic in it. Okay? So building an endpoint, building a microservice in this world, especially in Java, is super easy. It takes what you just saw there, and I need to add a little logic to it. So it wouldn't be that hard. The hard part is getting it running in a Dockerized world, in a containerized world. So let's show you that. So let me add a little logic to it real quick. My REST controller. Here, let me put these on so I can see properly. Yeah, that helps. Okay, package, com. There we go. And then we at REST controller. Okay, public class, my REST controller. And then I can say request method. Helps if you spell request method correctly. Request mapping. And then we can do this. Okay, public string index. I'm just using Visual Studio Code, by the way, if you guys are wondering what this thing is. And Visual Studio Code has both a Java debugger as well as the Java utility from Red Hat in here. So this is actually Red Hat's Java extension to Visual Studio Code. I use it for everything now. I don't use Atom or any other text editor anymore. This is my favorite text editor. So turn, hello, JavaDay. Okay? And I like always adding the date so you can see things change. So if I did that right, compile, package, should build me a fat jar. But there's still no Docker file, and there's no Kubernetes YAML. Uh-oh, what did I do wrong? Package Java util date. New. Yeah, okay. It actually did give me a syntax highlight there. I just wasn't paying attention. Let's see here. Come on, build, target. Okay, so there's my fat jar, java-jar, target, my Java demo. Let's see how that looks. Localhost 8080. There it is. Okay, there's our little application. All right, now, so easy. Build a REST endpoint, build a microservice, super easy. Now I want to run it in Docker land. So normally you would do a Docker file, right? And you would do a Docker build. You got to watch out for that thing I told you about earlier today, which was if you don't get the memory constraints right, it blows up. So you got to watch for that. Or you could just use the Fabric 8 tool. So like the Fabric 8 tool here, let me see here. I have it listed. Okay, here, whoop. I just copy and paste it. So I can come over here now to the command line, run the Fabric 8 setup, and there it goes. OC new project, JavaDay. And this actually is running very slow on this system. It actually is acting up a little bit for me, but let's see how it goes. So at this point, it's going to do the full build of that application, and it's also going to, without a Docker file and without any Kubernetes YAML, it's going to make some assumptions about that application. For instance, I put the actuator in there. That's its health endpoint. It knows that's the readiness probe as an example. And it can basically load it in to our Kubernetes world. So this works targeting a Kubernetes or an OpenShift. It doesn't make a difference. And you can see it's a little bit slow. Let's see here. kubectl get pods. And you'll notice that there's a build pod that's running. So it literally spins a pod up to run the build of that application to then produce a pod. I know it sounds kind of crazy. It's like Inception. But it works out very nicely, because that way you're doing the build not on your local machine, but you're doing it truly in the cluster with the right base images for that cluster. So if you have a certain set of images that require, let's say, Red Hat Enterprise Linux versus another type of Linux, and you want to make Red Hat Enterprise Linux your production Linux, it works that way, right? So that's the nice thing. You don't have to worry about the base image. It just takes care of that. And it's going to take a little while to run, so we'll just let that run for now. Okay, this system is very overloaded, as I showed you earlier, right? I got too many things running. That's part of the problem. And 6 gigs of RAM. So that's the easiest way to build an image, use the Fabric 8 Maven plugin, but there were a lot of other options on that list. One I would point out to you is one called Compose with a K. So if you like the Docker Compose YAML syntax, this converts it to Kubernetes syntax for you. And that's a nice tool. And there's also another tool that takes that basic syntax and uses it to launch it directly into Kubernetes called Kedge that we're working on now, another open source project that's super cool. All right, let's keep going here. There's also the concept of an exec. So this is like your SSH into a pod. This is incredibly valuable when you have to figure out, why is it not quite running correctly? Did my JVM start correctly? What's going on in the logs, things of that nature? So you'll want to be able to use this thing called the exec, E-X-E-C. And then you can basically shell into the machine, shell into the pod, and look around inside it. One word of warning, don't do this in production, because if you mess around with it too much, you could kill it pretty easily. You're basically in the actual pod that's running that service. To kind of make that point, let's see here. I'm curious, so did this guy ever finish? Or is it still chugging along? It did finish. Let's see here. kubectl get pods. Does it look like it's happy? It says it's happy. Okay. If it's so happy, actually, let's go mess with it. OC get routes. And by default, with OpenShift, you get a route associated with it. So let's do that. All right, there it is. So that's the thing now running inside the pod. So let's do this. kubectl exec it, the pod name. The pod name. I left off the H there. We'll have to get that back. Bin bash. Let's see if I did that correctly. PS ef Java. Okay. PS grep. So I basically am now inside the pod. So this is a very powerful thing for you guys to check out. If you came to my talk earlier, I talked to you about the fact that you really need to make sure you check out all these C group settings, and it's good for you to poke around in there, right? Like, CPU, things of that nature. So do check out those C group settings, and that's one great example. Is my JVM happy or not? You might even want to know what Java version you're running. Looks like this is 141 as an example. So real powerful tool, good to know, the exec function. All right, is this cool? Is this what you guys wanted? Man, you guys are quiet. Either that, you're asleep, and you're ready for just the giveaways and the prizes. All right, let's talk about logs real quick. Typically, I use system.out.println all the time. I know it's not cool, but I'm just lazy and I don't feel like setting up the logging framework. But you just add system.out.println. Anything that goes to standard out is automatically captured in a Kubernetes OpenShift world. Okay? So in other words, we're gathering all that standard out information and pulling it together. You can decide what you want to do with that, but there's a really awesome little utility called kubetail. So let's see, actually. Let's see if it'll run for me. I want to go back over here. Let's see. I was starting this little set of microservices. Let's see if they come up for me. Okay, good. All right, it's very simple. We'll show you the code. But basically, this is an example where service 1 calls service 2 calls service 3. That's what you do in a microservices world, right? So to kind of make that point, do project. How about typing correctly, Burr? Micro world 2. Switch projects, okay, good. kubectl. You could actually do it with kubectl-n. I just don't, I'm just lazy. So I like switching projects, switching namespaces as opposed to typing the namespace all the time. So those were 3 pods. Here, let's try that again. So kubectl, exec, and bin bash. Okay, curl, hp. What's that one called? I forgot what it's called. Where'd that piece of code go? Yep. So number 1 is going to call it's just the name of it. So this is actually a point that's important. Would that work? There's going to be an 8080. No. No, it's not 8080 in this world. Or is it 8080? I can't remember. The customer, that's what the problem was. There we go. So in this case, you can see basically I'm inside pod 1 talking to pod 2. So when we talk about service discovery in a Kubernetes world, basically it's manipulating DNS for us. And so you just refer to it through its DNS name or its service name. So you can think of this as the service name. And in this case, since I'm talking directly to its service, it's through 8080 in this case. So you can kind of see that you can do a lot of interesting things that are inside here, but watch what happens now. Let's actually get back out of here. Okay, kubetail micro spring. Okay, this is neat because you can actually tail all the pods, in this case that happen to have the same name. I can tail all those pods. Is this the guy? Oh, this one. Right here. Make this smaller. All right, there we go. So in this case, you can see there's all the logging output across all those pods. So this is incredibly valuable if you are dealing with more than one service, more than one pod. You can use this thing to say, hey, grab all the logs, tail them together, and let me see what it looks like. And this is a simple little application that's just basically grabbing customers, grabbing orders. That's all. Okay, so that's a very handy tool. We're doing okay on time, I think. Let's see here. All right, so definitely know how your logging works. That helps you from a debugging standpoint. We just kind of showed you the basic service discovery, and you get load balancing for free in that. So that's something you should be aware of. Let's see here if we can make this work. This is a different example. Come on. Query. All right, so these are the namespaces I have on this. Let's look here. There's the JavaDay one. But let's actually create a new one. So I like to script things because it makes it easier for me. Okay, so we created a namespace called kubedemo now. So kubectl get pods. There's no pods in that one. OC project, kubedemo. And let's see here. Okay. So we are in the kubedemo. I can create a Docker image. There's one already out here. And actually, let's do this to make sure I am definitely talking to the right one. As I said, you tend to forget which client is pointing to what server. So here's an example where I'll make sure I'm pointing at the right server. Okay, Docker images. Grep. Okay, 20 seconds ago. All right, that's the one. Now, you can create the pod. Normally, if you don't use the Fabricate Maven plugin, this example nicely kind of shows you what it would be if you had to basically do it the manual way. So the manual way would something like this, right? You would say kubectl, the namespace, create-f. So you see this a lot, create-f or apply-f, and the name of the YAML file. And you can see this YAML is just a deployment right here, type deployment, and it basically names the image. So my vertex tagged v1. And then it also adds the liveness probe and readiness probe. So this is what you'd normally do without the Fabricate Maven plugin, is something of this nature. But it does allow you to do some pretty interesting things. So let's say we created the pod. Let's expose it as a service. Let's curl it. Oh, Actually, let's come over here. So curl, new. Let's see if we can curl that guy. OK, so there we're curling it. And one of the things I'll do is just simply scale it up. OK. So in this case, much like I said earlier, Kubernetes will ensure that if you need 3 of them in this case, it'll keep 3 running for you, and you'll actually see it just dynamically load balance across it. So again, service discovery load balancing is kind of built in. That's why you don't need something like a Eureka or a Ribbon in a Kubernetes architecture. You can still use them if you choose to, but they're not required. And you'll notice here it's actually displaying the host name that it's coming back on. Okay? And if I go back to my main web UI over here, specifically, you can kind of see it from a web user interface standpoint too. There it is. That's the one we just did. So there's the 3 pods we just did. So you can also see it do the rolling update, which is a standard Kubernetes feature. Okay? Well, let's do the run the rolling update to make it interesting. Let's bring up the code again. Main vertical. Hello from Vertex. Let's see if I can make this work. All right, we just changed the code. Okay. And I script all this to make so I can remember it. So prepare the update basically does a Docker build. See, it says Docker build v2 right there, the version 2, because I just made an edit to it. So if I go Docker images, grab Burr, you can see there's the version 2 one 8 seconds ago that we just did. And I can basically now roll that update. So in this case, it's basically making what was v1 now v2. And if you watch the user interface, you can kind of see that happening right there. Okay, so it's going through the process of rolling that update out, and you can kind of see it change over here on the other side. So that concept of a rolling update is just something you get for free in a Kubernetes world. It's the feature they've had ever since the very beginning. It's often very magical for people. If you've ever had to do this on your own by configuring a big IPF5, which is not fun, it's kind of a cool feature. And one thing that's super neat about it is you can kind of undo that too. So I can roll it back, okay? And you'll see it start going backwards from the previous one. There we go. I didn't let the first one finish. That was probably not nice. But basically, all 3 of those are being load balanced across, and now we're rolling backwards. You can still see there's some old ones in there. Okay, but that's just a standard Kubernetes feature. And the cool thing is you can do all that just exploring on your laptop, right, with this Minikube, Minishift that you see me working with here. Let's do this, okay? So service discovery, load balancing, you get for free, okay? So keep that in mind from a services standpoint. It's just a service name. It's just manipulating the DNS. And actually, let's just do this. kubectl get services. Okay, you can see there's the load balance service right there. So the service is something that's created as part, a native aspect of using Kubernetes. All right. Okay, so all these examples, as I was just showing you, are available to you guys also. And again, if you have access to the slides, you have access to these samples. But we have more to show you. This one's going to be kind of fun. Hopefully you guys have a smartphone ready. This is more entertaining if you try it. I mentioned earlier when you move into this world of Kubernetes from just regular Docker, you get this YAML file you typically interact with, or you can use the Fabricate Maven plugin or one of the other tools. And in the YAML file, you'll see this thing called a liveness probe and readiness probe. So the liveness probe is simply, are you even aware that you're up, right? Not that you're ready to receive traffic, That's the readiness side. The liveness says, are you alive or not alive? If you're not alive, in other words, if you don't respond to that request, the Kubernetes basically decides, okay, you're dead. I'll restart you on another node in the cluster, kill the previous one. So being alive is an important state. The next phase is, are you ready? And that's when the load balancer will send you traffic. If you're not ready, no traffic. If you are ready, you get traffic. And the cool thing is you can do some really interesting things with those two readiness, the liveness probe and readiness probe. You can put business logic in there. You basically can hit your database. Yep, the database is up. I can pre-cache everything I want in the memory, and I can basically then return, I'm ready. And by being ready, all you're doing is returning a 200. That's all it is. And so we came up with a clever example of this. I think it's clever. You guys will have to tell me. And so what I want you to do is go to this URL. Let's try this, movies.burr.red. Okay? Who's got their phone out and wants to try this with me? We'll see if this works. So, I showed you how we could do a rolling update. Here's what we want to do. We want to do a rolling update with stuff in memory. So in this case, you can put stuff in your shopping cart. Let me do this right here. I'm just adding some stuff to my shopping cart. Okay? We just randomly pull movie titles off the internet. So I have these things in my shopping cart. Same thing on my phone. I can do it on my phone, and this is what you guys should do too. Okay. Let me do that on my phone just to see it work here. Just add some nice things to the cart. And that Thor movie looks like it'll be interesting. So basically, you have it, in your application, or your application's running in the set of pods. This is actually run on a different OpenShift cluster. And what I'll do now is we come over here to this application. What I've done is I made the edit previously. I made the edit previously to change the title on the shopping cart page, just to kind of give a basic example. But you can see right here, here's the readiness probe. It calls to this thing called health Z. If I look at this is a standard Spring Boot application. And if you look at the home controller, I think it is, yeah, here it is. So there's the health Z, and it's specifically saying, is my cluster ready? Just like I mentioned earlier, is my database ready? Is my cache ready? Is everything ready? That's when you return a 200, okay? HTTP status okay. Once you're ready, it sends load your way. And where did I make that change to the actual application? Is it here? Yeah, so I basically put JavaDay UA. I already did the Fabricate deploy, so you guys don't have to wait for that to happen. And it's running on this server that's out here on the internet. Let's see if I can find it. Okay, not that one, but okay. I gotta find the right place. And hopefully it didn't time out on me. Let's see here. Okay, so basically we have two pods that you guys are already interacting with. If you look at the bottom of your screen, by the way, you'll see the host associated with your application. So see right here? I know it's tiny, but you'll see that there. So that's specifically the server you're tied to. Each pod, each container, is its own server, right? That it's just like any other server you could SSH into. That's what we did with exec. In this case, you can see that. What I'm going to do is I'm going to basically spin up now. This is the one that has JavaDay in it. I'm basically going to say roll it up, spin it out, and roll it out. So if you're thinking in terms of canary deployments or any kind of nice deployment interval, it takes about 60 seconds to roll out. Again, let's look back at the YAML here. Where'd that YAML file go? Right here. Okay, see where it says initial delay 60 seconds? So you'll notice it takes about 60 seconds for that pod to become active. That's what we're doing. Okay, so you can see it's basically live, not yet ready. See, it says not yet ready. But as soon as it becomes ready, we can start sending traffic to it. And so let me go back to my little shopping cart application. Okay, I'm just going to hit refresh here. It still says my shopping cart, refresh. Okay, which is what I expect. Let me refresh my phone. You guys refresh your phones? You guys still see the old one, right? Well, let's kill the old one. And let's see how fast we can do it. Let me really kill the old one. Let me go back up to that page. And hit refresh. And notice that the code changed, my data's the same. Did it work for you guys also? Who tried it? Did you guys get your data? So, think about that for a second. People like to say, well, in this cloud native world, you gotta be 12-factor, you gotta be stateless. Not necessarily. In a Kubernetes world, you can be as stateful as you choose to be because it has these additional capabilities, including the ability to mount persistent volumes and deal with storage from a file system standpoint. In this case, we're dealing with it only in memory. Literally, all the memory was replicated from the original pods to the new pods based on that liveness and readiness probe. That's all it is. So it's a very powerful concept, and that's why I included in this presentation. And if we want to, we could just roll it back. Our users, our customers, our marketing people could say, oh, that's not the version we wanted, and I could roll it right back. But we're not going to wait for that, All right, but that's where I think the live and readiness thing are super powerful, super important to understand. And all you have to do is simply specify them and add the URL, right? I want an HTTP against this URL, a GET request or a POST, whatever you want, and it'll call it, and you return 200 or not 200 for the answer. So there's lots of good examples, and you'll see that same example all out there from a demo standpoint. We kind of already showed you the rolling updates. And as far as blue, green, and canary goes, actually, we have a few minutes left, so let's do this. I'm going to try to change something real fast. Let's see if I really blow things up now. This is where it gets entertaining, even for me, because who knows what's going to happen here. Profile list. One of the things that's been added recently to Minishift Minikube is profiles. Minishift, by the way, is based on Minikube. And I just got them working recently. So let's do -- profile. And I want to basically say hello world MSA. That's the one we were just looking at. And I want to stop it. I'm basically killing that virtual machine. You should see it stopping over here on my VirtualBox. I tend to use VirtualBox, though most people use that X-Hive virtualization on a Mac. I don't really like it. I like VirtualBox because it's everywhere, right? It's the same virtual machine everywhere I go. But there we go. We stopped it. Let me see if I can start this other one. It'll take a little while. But basically now I'm switching clusters on the fly. And this is where it can get a little interesting. And this is literally a brand new thing, right? This concept of profiles. You can switch things easily without destroying an old cluster and rebuilding it again. You can basically stop it, start it, stop it, start it. And so this weekend has been my real first testing of this idea. So in this case, it's bringing up a new one, and it might take a little while. But let's just jump back into slide mode while that thing cooks around, okay? So blue, green, and canary I showed you last year. That's the reason I didn't just bother showing you again. It's super easy with Kubernetes. It's a no-brainer to do a blue-green deployment. It's a no-brainer to do a canary deployment. And as a matter of fact, with that rolling update feature, with that readiness probe, that is doing a canary deployment for you for free. Because if you don't return ready, it doesn't send traffic your way. Until you return ready, then you get some traffic. And then it finishes the rollout across all the pods. So if you have 3 pods that have to be replaced, it goes in 1, 2, 3, based on ready, ready, ready. And then the traffic gets routed to each one as they become ready. So it is a canary deployment by default. You get built in out of the box. So that sort of stuff is super easy. And so if you want more on that, there's a whole example that we provide that shows you blue-green deployment, canary deployment, also Jenkins, CI/CD, automated deployment, pipeline deployment. We're not going to worry about that too much. And actually, I just took this cluster down. But there's also a debug command in the Fabric 8 setting. So we did Fabricate deploy to deploy our pod. You can also do Fabricate debug, and it does a port forward, so you can run your regular IntelliJ, Eclipse, NetBeans debugger against that pod directly, which is pretty awesome. So if you are using a Maven Fabricate plugin to do your deployment, you can also use it for debugging. And I also use Visual Studio Code, which just added the debug feature just in the last month or so. So that's a nice thing. Let's talk about Istio real quickly. Because this is where, as I mentioned, in 2018, this is going to be the thing to talk about. So you heard it first for the first time here, okay? This is going to be the thing that everyone's super excited about. The concept of Istio is simple. It's actually this service mesh concept. Sam Newman mentioned it in his presentation earlier, yesterday. And it's incredibly powerful if you understand Kubernetes already. If you don't understand Kubernetes, then it might seem just like magic. And here's what it will do for you. It basically intercepts all the traffic between all the different pods, okay? And it allows you to manipulate that traffic on the fly to do what you want with it. And if my VM comes up correctly, we'll show you that. So with the concept of the service mesh, Istio and Envoy, you'll be able to do things like really intelligent routing. So rolling updates, get for free. Blue-green, easy. Basic canaries, easy. All super easy. Now, you can go to the next step. For instance, I only want customers in the state of Alabama who have an Apple iPhone to access this particular version of the software. You can get very fine-grained with the types of people you want to send traffic to. So you can do things like a dark launch. Dark launch meaning I want to actually put all my code in production, run all those pods, but I'm not going to send anybody to them. I'm going to sample traffic and send it to those pods, but they're not going to actually respond to any real human user. That allows me to do a lot of testing in production. So these concepts you'll see in this world, including things like distributed tracing and circuit breakers, will be at the infrastructure level, not in your business logic per se. So you're actually going to gain a ton of new superpowers in this Istio world. Let's see if it comes up. This is the architecture that you'll see with it. Here's your pod, your container. Notice there's a JVM in my case. I have a service A. And then there's this sidecar concept. The sidecar means it's just another container living in the same pod. They have the same life cycle. That's the beauty of a pod. Multiple containers can live in there. So the sidecar container will intercept all the ingress and egress traffic from that pod. It's basically, think of it like Wireshark gone crazy. That's how I like to think of it. So it's going to intercept all the traffic, and basically the pilot allows me to change configuration, change rules. The mixer allows us to grab data for doing distributed tracing for free without adding all that to our code. So this is why you don't need things like Zipkin any longer. You'll get tracing built into this solution. And actually what's funny is they actually ship the data to Zipkin anyway. You just don't have to add it to your code. You just get that at the wire level. So it's a very powerful concept. And so here's the demo. If it'll work for me, we'll find out. It has these concepts. It has this product page, details page, and these reviews. Let's see if I can get it to run. Okay, looks like it came up. Let's do this real quick. OC login. Make sure I'm logged in here. Okay. Mini shift Docker env. I want to make sure I'm connected to it correctly. Okay, boom. And let's do this. kubectl get namespaces. And OC project. Istio system. I'm seeing if it came up cleanly. And kubectl get pods. All right, it looks pretty good here. Now, first thing you'll notice when I bring up this right now, you notice it says 2 and 2. You normally never see 2 and 2 because you only had one container per pod. That's because there's 2 containers in each pod, and therefore 2 have to be ready. So that includes the Envoy sidecar as well as the actual component of the application. Let's see here. I have a demo script, and let me do this. Nope, not that window. Too many windows. Let's close that one down. And I think this is number 11. Here we go. Here we go. Here we go. All right, let's make sure we're running correctly. We're almost out of time. All right. Let's see here. Come on. Looks like it's all running from the console standpoint. Okay. So remember, there's 3 pods specifically running for the concept of reviews. So see, it's reviews 1, 2, and 3 running right there, meaning there's 3 copies of the software running. One gives you red stars, one gives you no stars, one gives you black stars. And so you can see it's just randomly load balancing across those services. That's what you get for free with Kubernetes. Random load balancing you get out of the box. So that's the default behavior. But with Istio, you can come in here and do this Istio name of the namespace, create a rule. In this case, it binds it to version 1, which version 1 has no stars. So now all users see no stars. Let me show the next one. This one basically does the same thing with version 2. Now everybody sees only the version 2 of that application. So all traffic is going to that second pod. If I come over here and make it version 3, you'll see that everybody goes to version 3. Okay? There it is, the red stars. Let me go back to version 1. And here's where it gets kind of interesting. So the next one is where we basically said only let users Burr get access to the third pod. So let me actually sign out here and make sure we're doing this correctly. Sign in. Okay, so Burr, get the password correct. So Burr sees version 3. All other users see version 1. Which is kind of cool. And then you can even get more creative with it. You can basically inject a delay, a network level delay at the rule level. So let me log back in here as Burr, and you should see it hang for 7 seconds. This allows you to actually test the resiliency of your microservices and see if those circuit breakers are working correctly by adding a network fault in this case. So this thing does a lot more than what I just showed you. You can see it failed in this case because it did not wait long enough from an application standpoint. And you can see it'll take another 7 seconds now to refresh the browser. So this is where a lot of people are going to be going. It's going to be super awesome. Jeff's definitely spent some time checking that out. And I can actually clean up all those route rules too and get back to a nice old state that we were in before. Okay? All right, let's get back to our slides and we'll wrap up. There's a lot of other things that we could show you. There's all these bonus options. We have a cloud-native IDE, specifically the Eclipse J team is not too far from here, about 3 hours away. You can run a browser-based Kubernetes native application called an IDE. In this case, a full IDE running in the browser, running inside Kubernetes pods. There's a bunch of resources available to you, specifically these ebooks you can download for free. Also, I recorded about 2.5 hours of microservices training related to the demo you saw earlier that's available to you. And there's this really awesome book you saw from Edson Yanaga last year. He was here last year. He finished up this book on how to deal with monolithic databases. And everyone's going to have this problem. If you have a monolith today, you have a monolithic database today. And as you move into the microservices world, you want to basically see that, see the techniques specifically in this book. Remember, all this is at that bit.ly link at the bottom. And, you know, that's the one you want. bit.ly, 8 steps, awesome. And I'm out of time. But will stay around and answer questions for you guys as I can. Thank you guys so much.
Thanks a lot for talking.